Okay, we're going to go over today's tasks that we did on the whiteboards. Okay, so we've got these different graphs here, and we're trying to find the domain and range and whether or not they're a function. So first of all, I can draw a vertical line anywhere on this graph. So this is a function. Okay, so this is a function. Okay. And the other thing is, so what is the domain? So if you look here at your graph, you can draw, uh, there is an x value for any x value at all. The arrow goes this way forever, the arrow goes that way forever. So my domain is x is an element of all real numbers. Okay? And same thing with this one here. There is there is a value for every single x available. So the domain on this one is x is an element of all real numbers. Okay? This is not an IR. This is just a funny looking R. They write it like that with two lines. Okay, range. Um, every y value has to be above -4. So my range is y is greater than or equal to -4, because it's always going to be higher than -4, so it's greater than -4. Um, Over here, the only value that works for for the range is y. Y has to be 2. Y equals 2. Okay. Now, and this is a function also. If I drew a vertical line anywhere, let's just draw it right here. It doesn't matter where you draw the vertical line. It only goes through the graph once. That makes it a function. Okay. The other two that we did, this is not a function. Because if I drew a vertical line anywhere, you see how it goes through twice. Okay. We still have a domain. So my domain, this goes forever to the left, this goes forever to the right, and it's everything in between. So the domain is also an element of all real numbers. Same thing with this one. It goes forever to the left, forever to the right. The domain on this one is all real numbers also. Okay. Um, if I draw a vertical line anywhere here, it only goes through the graph once. So this is a function. Okay, let's talk about range. For this one here, it has to be greater than 1 or less than -1. So, so my range is y is greater than or equal to 1. That makes it go up. And y is less than or equal to -1 because it goes below. But it's nothing in between there. Now, on this one here, the range, the y values have to be between 5 and -5. There are no y values above 5. There are no y values below 5. So my range is between -5 and 5. Okay? You might want to hit pause and copy this down. This is useful for having in your notes. Okay. So, task 2. basically what we're going to do is wherever you see x, we're going to plug in the number that you see there. Okay? So f of 2 simply means we're going to plug in so instead of putting an x here, we have a 2. So this means when x is 2, we have 2 times this red 2 minus the red 2 squared. And then we simplify that, and we get 4 minus 4, which is 0. Okay. For b, we have f of negative 3, which is equal to 2 times negative 3 minus negative 3 squared. Okay, there was a lot of people who had trouble with this one because they made some sign mistakes. So here I've got 2 times negative 3, which is negative 6. Everybody got that right. And then I have this minus. And then negative 3 squared, this is negative 3 times negative 3. And what is negative 3 times negative 3? Positive 9. Right? So this gives us positive 9. This is positive 9. But we still have this minus the positive 9. So our answer is going to be negative 15. Okay. Last one. C, we have f of negative 1/2. So we've got 2 times negative 1/2 minus negative 1/2 squared. Okay. So I've replaced x with negative 1/2. Okay. 2 times negative 1/2 is going to give me negative 1. And negative 1/2 times negative 1/2 is positive 1/4. And then now we get this is equal to negative 1 and a fourth. Okay. Or you could say negative 5/4. Or you could say negative 1.25. I don't care what answer you write. Any of those will do. Okay. Task 3. Okay. A lot of people took a lot of time on this, and this is good. It's good for you to practice this. So we're going to replace the x with all of this stuff here. So for a, I can say g of x plus 1 is equal to x plus 1 squared minus 3 times x plus 1. So instead of putting the pink x and x, instead of writing this pink, I'm going to replace it with x plus 1. So this pink thing squared minus 3 times this pink thing, right? This pink thing squared minus 3 times the pink thing. This pink thing squared minus 3 times the pink thing. That's probably a good way to think about it. Okay, so now the mistake that everybody was making is they didn't know how to expand this. So you need to think of this as, I'm going to do it over here. Think of it as x plus 1 times x plus 1. If I've got x plus 1 squared, this is x plus 1 times x plus 1. And now we have to do this thing called FOIL. So the first thing times the first thing, which is x squared. The outside thing times the outside thing, so x times 1, which is x. The inside, I is for inside. Inside thing times the inside thing, so 1 times x, which is x. And L is for the last thing times the last thing, which is 1. And then that simplifies to x squared plus 2x plus 1. So this is what this is. So I've got x squared plus 2x plus 1. And then we have this negative 3 times negative x is negative 3x, and negative 3 times positive 1 is negative 3. Okay, and then I can combine the like terms, and then I end up with x squared minus x minus 2. Okay, so the orange foiling part is where people were making mistakes today during the whiteboard activity. And for question B, this marker is not very good. I need a new marker. Okay. Maybe this one will work. Purple. Woo! Okay, so g of x squared minus 2 is equal to x squared minus 2 squared minus 3 times x squared minus 2. Okay, so once again we need to FOIL this. So I'll do it down here. Okay, so we have x squared minus 2 times x squared minus 2. Okay, so if I FOIL that, x squared times x squared gives me x to the 4th. X squared times negative 2 gives me negative 2x squared. Negative 2 times x squared gives me negative 2x squared. Negative 2 times negative 2 is plus 4. Okay, so, and then this, I can combine the middle terms, and I get x to the 4th minus 4x squared plus 4. Okay, so this is what this is going to become. So this is equal to x to the 4th minus 4x squared plus 4. Okay, and then we have negative 3 times that gives me negative 3x squared, and negative 3 times negative 2 is plus 6. Okay, combine the like terms, and we end up with x to the 4th, and negative 4x squared and negative 3x squared is negative 7x squared, and 4 plus 6 is going to give me 10. Okay, and then the last page, task 4. Just like the others, the domain is x is an element of all real numbers. And same thing with here. There's no value that doesn't work for this. So the domain is x is an element of all real numbers. Okay, the range. So the range is y is greater than or equal to the y value, which is negative 5. Here, the range is y equals 1 and y equals negative 3. Because y can only be those values. Okay, is this a function? Both of these are functions. Why? They're both functions because for every x value, there is only one y value. I could do a vertical line test. If I do a vertical line test, it only goes through once. If I do a vertical line test, it only goes through once. And even right here, where you see this open circle, that means a hole. So I get to that point and it doesn't actually cut through. But I've got a solid dot here. So even if I drew a vertical line here, it still only goes through one spot. So that still is a function. Okay, x and y intercepts. So the x-intercept here is -1 and and 5, and then the y-intercept is -25/9. Over here, there is no x-intercept. It doesn't cross the x-axis, and the y-intercept is only 1. I could write it as a coordinate pair. I could write this as um, 0, 1 if I wanted to. I could write this here as 0, -2/9. I could write these x-intercepts as -1, 0 and 5, 0. That's fine too. And there we have it.